Hi everyone, I'm Mo Yuan from Alibaba Cloud Kubernetes team. Today, my topic is saving cost with Autoscaling on ACK. Here's the outline of this topic. First, we will talk about what is Autoscaling and why we need Autoscaling. Then, I will introduce how to do Autoscaling on ACK, give some example of typical scenes. Finally, I will show a HBA demo based on external metrics. In a recent search of over 900 tech leaders, we discovered that migration from IDC to public cloud and the private cloud is still accelerating. The adoption of cloud-native projects is more and more common. Kubernetes adoption is growing so fast. It is set to jump from 20% to 30%, 10-point increase by 2020. More than 56 of tech leaders care about how to improve resource utilization. Kubernetes is a standard cloud-native interface to help to accelerate IT infrastructure transformation. Saving cost is the top one factor to be considered. So, how to save cost on Kubernetes? Here's a chart about capacity planning and burst resource usage. The yellow area is actual usage of your workload, and the red one is about capacity planning. When the red line is upper than the yellow area, that means you have enough resources to run workload. But the larger the spacing, the more you waste. When the yellow area is breaking through the red line, that means you don't have enough resources to run workload. Even the running workload may be affected of insufficient resource. Is there any ways to solve the conflicts? The answer is yes. Autoscaling is the chosen one. On the right side, we have two real custom utilization charts on ACK. In the first chart, it weighs about 40% resource to guarantee the availability of the cluster. It's not good enough, but it's real in a lot of companies. The second chart is about resource utilization when used Autoscaling on ACK. The spacing between capacity planning and the burst resource usage is changing with each other and keep it at a low level. It helps to save about 30% of the cost. Autoscaling is a game between capacity planning and burst resource usage. The better autoscaling you did, the more cost you save. In the next section, I will introduce how to do autoscaling on ACK. Here's the architecture of autoscaling on ACK. We have two kinds of autoscaling categories: application autoscaling and resource autoscaling. HPA is horizontal pod autoscaling. You can use HPA to autoscale pods based on metrics. VPA is vertical pod autoscaling. It's not that popular, and we will not talk about it in details today. Cron HPA is another pod autoscaling method. You can autoscale pods based on cron type rules. It's useful when you can know resource usage trend in advance. In resource autoscaling, we can autoscale plain VM instance, bare metal instance, GPU instance, and a spot instance. And we also have a unique resource autoscaling method called virtual node. You can regard virtual node as a giant node with unlimited resource. When pod scheduled to the virtual node, it will finally be created as a serverless pod without any node. HPA can autoscale pod based on three kinds of metrics. CPU and memory are the most popular resource metrics. Custom metrics is about the user-defined metrics such as the number of people online in your application and so on. Typical external metrics is about cloud service such as QPS of the load balancer. So the richness of the matrix determines the strength of elastic scalability. In ACK, we provide all kinds of metrics based on multi-dimension monitoring architecture. We have 4 kinds of monitoring cloud service for different application types. SS is the log service. It can collect application log, control plane log, and gateway log. ARMS is an APM cloud service for application performance tuning. You can use ARMS to visualize the status of GVM and deep dive into your application tuning performance. AHAS is an architecture awareness cloud service. When you are using microservice to structure system, AHAS can help you to visualize the network flow between different microservices. Cloud Monitor is the traditional resource monitoring service. We also have managed Prometheus service as an alternative choice to the open source one. Based on the monitoring architecture, we transform all kinds of monitoring metrics into 3 categories. In resource metrics, we provide CPU, memory, network, and so on. In custom metrics, we not only provide the standard metrics interface, but also typical solution about how to use custom metrics with our application. In external metrics, we convert all kinds of metrics we collected, such as log, APM, microservice, and others, as autoscaling factor. A comprehensive monitoring architecture makes HPA shiny. HPA is great, but not perfect. It may not scale up in time due to metrics scrapping. If you can know the resource utilization trend in advance, Cron HPA would be a great supplement to the plain HPA. Cron HPA can also work with HPA. You can define the time-based scaling plan like cron rules. Cron HPA is a standard CID implement, so it's easy to use and to do integration with open system. Node autoscaling is a kind of resource autoscaling method. The class autoscaler would watch pods changes from API servers. When the pods are unscheduled because of insufficient resource, class autoscaler would choose a scaling group to provision new nodes for the cluster. When the new nodes join into the cluster, the unscheduled pod would be rescheduled to the new ones. In Alibaba Cloud, 500 Kubernetes nodes can be scaled up in 90 seconds. Virtual node is a very unique resource autoscaling method. It is serverless autoscaling rather than the plain one. You don't need to care about what is the node and how many resources I need. What you need is to bound the pod to the virtual node. You can use node selector and the tolerance to do that. When the pod is scheduled to the virtual node, it will finally create as a serverless ECI pod. This kind of autoscaling method is very useful when you do CI/CD, big data, and jobs. It's fast, simple, and with low learning cost. In the next section, I will introduce some typical scenario. AI training with GPUs autoscaling is very common on ACK. When you create a TF job with GPU request, if the cluster cannot schedule the pod, class autoscaler will choose the best autoscaling group based on simulation of scheduling and the lowest cost. The GPU scaling group would provision a new GPU node with immediate container runtime installed. One GPU card bound to a single port is the most common way, but sometimes it's not the best way. because of the low resource utilization. We support GPU share scheduling and autoscaling. You can use GPU share feature to save cost. Multi-pods share the GPU MEM of one GPU card. Isolation between pods is also supported. And now it is demo time. In this showcase, I will introduce a real user scenario. Ingress is the most popular gateway in Kubernetes. For most of online services, CPU is not always the best choice to do HPA. QPS may be a better one. So how to monitor QPS of your workload in Ingress Gateway and how to do autoscaling based on QPS. In the previous section, I introduced the log service can collect the log of Ingress Gateway. It can also do some analysis on the log, visualize the net flow, and convert them as metrics with the help of Alibaba Cloud Metrics Adapter. Finally, HBA can calculate the replica of the workload based on QPS. So let's study the demo. First of all, you need to create a Kubernetes cluster. We have a lot of kinds of Kubernetes cluster type, and standard managed cluster is the most popular one. This type of cluster fully manage your master node and to help you save computing resource. You only need to create worker nodes to run your business. Fill the blank to specify your cluster name, select region, Kubernetes version, container runtime, and choose vSwitch of VPC. Select network plugin, port CIDR, service CIDR, and be careful if you want to manage your cluster on your own laptop. You need to choose a public size external expose API server with EIP. And if your cluster is very big, you need to create advanced security group. And then you need to choose instance type of your worker instance and select the size of the cluster, operating system, keep high. If you want to use Ingress in your cluster, you need to check this box, install Ingress controller, and choose correct SLB network type. Typically, we will choose public network because if you choose internal network, you cannot access the Ingress controller from internet. And if you want to use Ingress as custom external metrics to do HPA, you need to check this box, enable log service, and create Ingress dashboard. Then confirm order. Check this box and create the cluster. When your cluster is running, you can jump into the Manage tab to get some basic information. You can get the API server public endpoint, API server internal endpoint, and access log project, Nginx Ingress SLB, and the important ones is you can get kubectconf here, public access kubectconf, internal access kubectconf. They are different. If you want to manage your cluster on your own laptop from internet, you can copy the content and paste it to the kube folder. Create a file called config and paste the content. Then you can manage your cluster from your own laptop. Okay, let's create a deployment. Create from template. Select the correct namespace. Use the default deployment template, create. Then you can get a deployment here with 2 replicas. Let's create a service. Name the service as Nginx. Select class IP as service type. Select the backend we just created. And name the port. Okay, create. We will get a service called Nginx and create an ingress service. Name ingress service as Nginx. Select the domain. Fill the path. Choose the backend service. Okay. Choose port. Create. Okay. Then let's visit the website. Okay, it works. And we can find there is a link here called Ingress Overview. What is it? Let's click it here. That is Ingress dashboard. You can select a new time range, set auto refresh. You can view PV, UV, success rate, error rate, latency, and other useful information from this page. Then let's create an HPA based on QPS. Before we create the HPA, we need to install Alibaba Cloud Matrix Adapter. You can create Alibaba Cloud Matrix Adapter from Application Catalog. Click ACK Alibaba Cloud Matrix Adapter. And view the parameters. Typically, you don't need to change any parameters here. Just click create. And then you will get a deployment called ACK Alibaba Cloud Matrix Adapter in Kubernetes system namespace. And let's create an HPA. First, we can view the HPA YAML. You must use API version Autoscaling v2 beta 2 and use external type matrix. Fill the required parameters: SS project, SS logstore, and SS ingress route. The SS project is Kubernetes log class ID, and SS logstore is Nginx ingress. SS ingress route is namespace, service name, and service port. And the target value is 10. That means if every port has more than 10 QPS, then HPA controller will scale up new ports. Kube control apply HPA.yaml. We can watch this HPA. Okay, and we can use AB to simulate a stress test. AB, we can cite request to a very big value and connection to 10. Copy the ingress endpoint. Copy the ingress endpoint. and start stress test. We can view the ingress dashboard to check the stress. We can use ingress dashboard to check the stress. Here we can see the PV is increasing. Okay, let's check the HPA. We can find the HPA is working. Current red blood size is 4 and 5 is desired. And if the stress is stopped, HPA controller will scale down later. Wait for a few minutes, we will find the department has scaled down to 2 replicas. And thank you for watching for this topic.